Expanding and condensing logs. Okay, so before we can do this, we need to know the basic properties of logarithms. If you have a log base b of 1, our exponent is going to be 0. And that's because no matter what our base is, if you raise it to the 0 power, it gives us 1. If you have log base b of b, where your base and your argument are the exact same number, it's going to equal 1. And that is because any power or any base raised to the first power is going to give you that same number. So in this case, and I'm going to use that in these, you can use the circle of logs that we already have learned, but they're shortcuts, and these properties are like our shortcuts. So I know here my answer is 1, and that is because, remember, logarithms or logs are exponents. The only number that I can raise 19 to get 19 is 19 to the first power equals 19. Right here, you will not see a base 10 here because it's understood the common log has a base 10. So in order, oops, don't want to put 10, our answer is 1 here as well because 10 to the first power gives us 10. Same thing here is 1 because the natural log has a base e. Well, e raised to the first power is equal to e. So these three were the second one. These two are going to be the first one, okay? If my argument is 1, the only way I can get 1 is for my exponent to be 0. 273 to the 0 power gives us 1. The only way to get 1 as my argument is to have my exponent of 0 because any number to the 0 power gives us 1. So 1/8 to the 0 power is 1. Okay. Now again, you can always use the circle of logs that we learned earlier, but that's not what that section is for. Okay. Product, quotient, and power properties of logarithms. Now, there's only 3. Product, which is multiplication, quotient, which is division, and our power, which are exponents. So you have multiplication, division, and exponents. If you see this, we got to learn to expand it before we can condense it. And this is really important because when we go to solve logarithms, which is going to be our next section, we've got to use these properties. We're going to condense it, okay? But we've got to learn to expand it first. So multiplication, if you see multiplication, you're going to log base b of x times y. You can expand it by saying log base b of x plus log base b of y. If it's division, you can expand that as log base b of x minus log base b of y. And then if you have an exponent, that exponent is going to be moved to the front, and it's going to be p times log base b of x. Now, to me, it's pretty easy. This is how I think about it. Okay, I learned to multiply, well, we all did. We learned to multiply before we learned to divide. We learned to add before we learned to subtract. So multiplication and addition go together, and division and subtraction. Okay, those two. Now this is just totally different. You just move that exponent to the front. Okay, so first we're going to practice the multiplication, the product one. Then we're going to do division, which is quotient. And then we're going to do some problems with power, the exponent ones. And then we're going to throw it all together, mix and match. All right, so here we're going to have log base, I'm sorry, just log. I was thinking there was a little number here, but there wasn't. Plus log of x plus log of y. Now, you can write it like that, or you can put parentheses around it. Sometimes I will, sometimes I won't. And that's the answer. The only thing I'm going to tell you to be careful about is make sure this won't simplify. And it won't because 10, and when I say that to a whole number, you don't want an irrational number, okay? Log base 10 of 2, there's nothing I can raise 10 to get 2. 10 to the first is 10, 10 to the second is 100, so that's it. All right, I don't know why I did that up here. It would have given me more room down here, but that's okay. All right, the second one, I'm going to give myself more room. Log base 2, you got to remember our base, of 8 plus, because it's multiplication, log base 2 of x plus log base 2 of y. Now, the only thing you got to be careful about is when you have this, can we simplify it? Okay, now you can use your calculator, but I don't need to. Is there some power that I can raise 2 to some power that gives us 8? Yeah, that's 3. 2 to the third power gives us 8. So you have to simplify that. So you're going to have 3 plus 2 log base 2 of x plus log base 2 of y. Again, you can put parentheses around the x and the y if you want to. You don't have to. Now right here, here's our multiplication. It's 3 times a plus b, the quantity of a plus b. So we're going to have the natural log now of 3 plus the natural log of a plus b. And you're done with this problem because there's nothing you can raise e to get a whole number anyway. And right here, we don't have a rule for addition. We only have these 3 properties. There's no property with addition, so you can't do anything with that. All right, and that's the product property. The next one, here we go, is going to be the quotient. So we have division, so subtraction goes with division. So we're going to say log base 7 of z minus log base 7 of 49. The only thing you need to check for is, can you simplify this? Is there some number that you can raise 7 to get 49? Yes, 7 to the second power is 49. So this is 2. So you have log of base 7 of z minus 2. All right. Now your calculator will do that work for you, but I don't need the calculator. I mean, you can plug that in and see if it gives you that. Right here, log of 100 minus, because we have division, log of x plus y. Again, whenever you have a number here, you need to make sure that it can't be simplified, but it can. This has a power of 10. 10 to the second power gives us 100. So this is our answer. And remember, there's no rule for addition, only multiplication, division, and exponents. So we're done with that. Always double check to make sure it can't simplify. And this one right here, we have log base 7 of a minus, because it's division, log base 7 of 14. You just need to double check here. But be careful, they did this on purpose. It's not 2, because remember, 7 to the second power gives us 49, not 14, okay? It will not simplify, because 7 to the first power gives us 7, 7 to the second power is 49. This is going to give us some irrational number, and we don't want to simplify to that. Okay, now we're going to apply the power property of logarithms. Anytime you see a power, you're going to take it to the front and then see if you can simplify it. So that 5 goes to the front, so it's 5 times the natural log of x. And that's as far as it can go. Right here, we're going to take the 5 to the front. 5 times the natural log of e. And this is where some of you are going to stop and it's going to be wrong. And we just worked this problem right here. Natural log of e is 1 because This has a power of e, I'm sorry, a base of e. E to the first power gives us 1. So that, I'm sorry, e to the first power is e. So we have 5 times the 1, so our answer is 5. Now, granted, you can actually do this on your calculator and it'll give you 5. All right, right here. When we're dealing with logarithms, we do not want any roots. No square roots, cube roots, fourth roots, fifth roots, whatever. This comes back to your rules for exponents. And I can't remember if we did this in Unit 1 or not, but in Algebra 1, you learn how to change a fractional exponent to a root and vice versa, okay? This here is going to be x to the 2/3, okay? The root is your denominator. Again, the root is always your denominator. If you had something like the square root of x, and you needed to write that without the root and with a fractional exponent, this is x to the 1/2, okay? You should know this one in general, period, because taking the square root of something, hold on, I'll show you. If I take the square root of, let's say, 25, I'm going to get 5. But if I say 25 raised to the 1/2, or 0.5, okay, it's going to give us 5 as well. But again, there's really a 1 here. We don't write it. There's really a 2 here. The root is the denominator. So if I had something like the 5th root here, and let's say 3 right there, all right, the 5th root of x to the 3rd, or x cubed, it would be x to the 3/5. The root is your denominator. Okay, so now that I have this, we take that fraction and move it to the front. So you really have 2/3 log of x. Okay, now we're going to throw all those rules together. We're going to write it in expanded form. Write the expression as a sum. It may ask you just to do expanded form. It may write out the directions like this. Write the expression as a sum or difference of logarithms. Each logarithm should involve one variable and should not have any radicals or exponents. Assume that all variables are positive. Okay, so here's what we're going to do. We're going to expand it. I'm going to do this in 2 steps. I could do it all at once, but as soon as you start skipping steps, we start making careless mistakes. So this is multiplication. Multiplication goes with addition. So I can rewrite this as this natural log of x squared plus natural log of y, because multiplication and addition go together. Now, we can't have any exponents. We're going to move this to the front. So we have 2 natural log of x plus the natural log of y. And again, you do not have to have the parentheses around it. Just when I have variables is really when I like to put the parentheses around it. I don't care one way or another with the numbers, really. Okay, so now we've got multiplication here and we have division here. So we have log base 3 of 5 plus log base 3 of z minus log base 3 of w. And we can't, this cannot be simplified, okay? There's 3 to the first power gives us 3, 3 to the second power gives us 9. So, then again, you can put that around that if you want. You don't have to, either way. Now this one. There's a shortcut to this, but I'm going to show you how to do it first, and then I'll just tell you what the shortcut is, and we'll use the shortcut on the next problem. Alright, so we have log base 7 of a plus, because we have multiplication, log base 7 of c minus, now we have more than one thing on the bottom, so we're going to put that whole thing in the bottom in parentheses. Log base 7 of 5, and there's multiplication, so it's plus log base 7 of d. Okay? Now, because there's a minus sign outside of these parentheses, you're going to distribute that. That becomes negative, because negative times a positive is a negative. And that becomes negative, because negative times a positive is a negative. So the real answer is log base 7 of a plus log base 7 of c minus log base 7 of 5 minus log base 7 of d. The only thing you need to check for is, can we simplify this? No. 7 to the first power is 7, 7 to the second power is 49. We're done. Okay? Now, what's the shortcut? The shortcut is, and we're going to use it on the next problem, if it's on top, there are going to be plus signs or positives. If it's on the bottom, you're going to see minus signs or negatives. So I say if it's on top, it's positive, on the bottom, it's negative, because to me, negative and subtraction are the same thing. All right, so that's that whole answer. Now again, sooner or later, we got two more, I think 2 or 3 more examples. We're then going to go, I think, from here to here. Okay, but we have to learn to expand first. All right, so let me fix this. All right, right here. So I'm going to use that shortcut now. So if it's on top, I'm going to put a plus sign between them. If it's on the bottom, it's going to have a minus sign in front. So we have log base 8 of 64 plus log base 8 of x squared plus log base 8 of y. And again, you don't have to have those parentheses. Again, on top, so it's positive, plus sign, positive because it's on top, positive. Now these are on the bottom, so that's going to be minus log base 8 of 3. Because it's on the bottom, minus log base 8 of z. Again, you can do it like we did the last problem, but I'm just going to use a shortcut. Minus log base 8 of w to the third. Okay. Now, we got to double check to make sure this can't be simplified. We got to make sure this can't be simplified. We got to take care of our exponents. Now, is there anything I can raise 8 to get 64? Yes. 8 to the second power. Yeah, or you can use your calculator and it'll give you 2. We have an exponent here. We're going to take it to the front. And we also have another exponent here, so it's going to go to the front. Okay. And then we got to check to see if this one will simplify. All right, so here I'm going to say 2 log base 8 of x plus log base 8 of y. I cannot, there's nothing I can raise 8 to get 3. 8 to the first gives us 8, so an 8 to the second, 64. Minus, we're just going to leave it, log base 8 of 3. And if you do that on your calculator, it's going to give you some funky decimal. Minus log base 8 of z. And then minus, I'm going to move that 3 to the front, 3 times log base 8 of w. About ran out of room. Sorry. Well, that's our whole answer. It's long. Okay. Now, This one here goes back to our properties of exponents. We got to get rid of that radical first. So the first thing I'm going to do is I know that square root and 1/2 are the same thing. So I'm going to raise this whole thing. Instead of having a square root, I'm going to say 1/2. Because again, there's really a 2 here. We just don't write that in there right here. Sorry, I'm pointing at that one. Okay, now before I start doing anything expanding, I'm going to raise everything to the 1/2 power. Again, this comes back to your exponent rules. This is nothing new. When these have their own exponents. This has an exponent of 1, so does this, okay? And that one has an exponent of 3. When you are raising a power to a power, you multiply, okay? So really 4 to the 1 times 1/2, I now have 4 to the 1/2. Right here, the quantity of x minus 1, 1 times 1/2 gives me 1/2. And I also have to raise this 3 to the 1/2. Everything inside these parentheses. 3 times 1/2 gives us 3/2. Okay? Now, this right here, 4 to the 1/2 is the same thing as the square root of 4. Or you can plug that into your calculator and you'll get 2. So now let's start expanding. Okay, I'm going to go down here. I have log base 2 of 2 because 4 to the 1/2 is 2. Again, this isn't the only way to do this problem. You may have done it a different way and it works, okay? However it is that you do it. Plus log base 2 of the x minus 1 to the 1/2. And then division is subtraction, log base 2 of w to the 3/2. Okay, we need to see if we can simplify, and we need to take our exponents to the front. We need to simplify, see if we can simplify there, and take our exponents to the front. All right, is there any power that you can raise 2 to get 2? This is that rule, one of those properties. It's 1. When our base and our argument are the same, our answer is 1 because 2 to the first power gives us 1. Plus log base 2, oh, you know what? I forgot to move this. 1/2 goes to the front. So I have 1/2 times that, and it's a plus sign. Let me move this stuff, kind of squished it in there. Let's do 1 plus 1/2 log base 2 of x minus 1. And then that 3/2 minus, it goes to the front. 3/2 log base 2 of w. Okay, we got rid of our radicals and we got rid of our exponents. Okay, now this is why we had to learn how to expand, because now we can write it as a single expression or a single logarithm. That means we're going to condense it. So I don't know what your instructions are going to say in ALEKS, or whatever program you're using at the time. Okay, because this is subtraction, we know it's division, and you can't mix and match like a log and a natural log. Notice these are both logs, these are both log base 2, these are all natural logs. They're not going to, if they're different, then that's handled differently. But for now, they're going to be the same. Okay, subtraction goes with division. So to write this as a single log, we're going to put this on top. It's positive. So we have 4x minus 3 on the top, and we have x on the bottom. And let's see. Okay, it says write the logarithm expression as a single logarithm with a coefficient of 1. That means there's no number in front of that. Well, there is. It's 1. We just don't write it. And then simplify if you can. All right, so that was pretty easy. It won't reduce, so we don't have to worry about it. Right here, we've got two things. We have addition, and we got this number in front. This coefficient, it needs to be 1. Well, how did it get there to begin with? Remember, it was an exponent. So we're going to put it back as an exponent, because when we expanded it, we took the exponent to the front. Now that's not there anymore. Okay? So we can write this as a single logarithm, log base 2. There's a plus sign, so it's multiplication. So it's going to be z times y to the 4th. And that's it. Right here, this needs to be a coefficient of 1. We're going to put it back as an exponent. So we're going to have the natural log the natural log of, this is positive, so it goes on the top, x to the 3rd. This is negative, so that x minus 2 goes on the bottom. And this is minus, so it goes on the bottom. Now you can write it like that. I don't like this x to the 3rd's not centered. The other thing that bugs me, okay, this is perfectly fine. Yes, you can put 5x minus 10. That's fine. If this is me writing it, I'm going to write it like this, x to the 3rd over, and I'm going to put that 5 in front, x minus 2. Okay. Either of these answers are fine. Same thing with if you went ahead and multiplied this out to get 5x minus 10. That's perfectly fine. There's nothing wrong with that. Okay. The next problem. Okay, so what I'm going to do is I'm first, now again, you can handle this different ways. This is how I'm going to handle it, okay? I'm going to say 2 times the natural log. I'm going to distribute this 2 over these two first. 2 natural log of x minus 2 natural log of x squared plus 2/3 natural log of z to the 9th minus the natural log of z. Ooh. Don't know where I got the g from. Don't even, let's try this again. Natural log of z. Okay. So, first things first. We can't have these. They need to be coefficients of 1s. So I'm going to move this 2 to an exponent. I'm going to move this 2 to an exponent. And I'm going to move this 2/3 to the exponent. And let me put parentheses around this. I started to earlier and I didn't. So 2/3. Okay. That's going to get rid of our coefficients. So we're going to have natural log of x squared minus the natural log of raising a power to a power, you multiply. So 2 times 2 is 4. So you're going to get x to the 4th. Right here, you're going to have plus natural log of z. Raising a power to a power, you multiply, and that's going to give us 6. Okay. And then and again, your calculator will do this for you if you're not really good at multiplying fractions. Minus the natural log of z. Okay. Now that we do that, now we can write it as a single logarithm and then simplify. So we have natural log. This is positive, it goes on the top. This is negative, it goes on the bottom. This is positive, it goes on the top. This is negative, it goes on the bottom. And the only thing is we have to simplify this. And using our rules for exponents, okay, it's going to be the natural log of z to the 5th over x squared. You're going to subtract your exponents. Make sure you don't have negatives. Okay, take them to the bottom if they're on the top. Take them to the top if they're on the bottom. The way I look at this is I look at it and go, okay, we got 2x's up here. We got 4 down here. Which one has more? 4. How many more? 2 of them. This one has 6 up here. This one has 1 down here. The top has more. How many more? Z to the 5th. Okay. All right, this one right here. Again, we're going to take this, take it, make it an exponent, and that'll make sure that we don't have a number here. That goes away now. And now we have our coefficients 1, so we can write it as a single logarithm. We have x, it's positive, it goes on the top. Okay, this was positive, sorry. Minus sign, this goes on the bottom. We have x plus 5 squared on the bottom. This is positive, it goes on the top. So we have x squared minus 25 on the top. All right, now we just have to simplify. Log base 5 of x, this will factor as x plus 5, x minus 5. Still factoring. Told you it was going to be important. Down here we have 2 of these. What this means is x plus 5 times x plus 5. Okay. These cancel to give us 1s. So we are just left with log base 5 of x times x minus 5 all over x plus 5. Now, if you want to, you can write this as x squared minus 5x. That's fine, but you do not have to. I'm just going to leave my answer like that. Okay, and that finished up that section.